Hello and welcome to today's lesson. My name is J. Double, and today we'll be looking at probability. We'll be looking at the fundamental concept of probability. So without much ado, let us begin. Probability is how likely something is to happen. So in mathematics, we basically compute the probability of events to see how likely those events are to occur. Okay, so we say in mathematical terms, the probability of an event is basically the number of ways the event can occur divided by the total number of outcomes of that identical event. Okay, so that's basically probability. So some authors will say the sample space. Okay, the sample space is just the total number of sets, within the outcome of that identical event. Okay, so in other words, we can also say probability is equals to the event over the outcome. So in order to look at the fundamental concept of probability, we are going to use three different items, okay? Three items that are most commonly used in determining the probability, in actually explaining the fundamental concept of probability. And those are the coin, the dice, the ludo dice, and the playing card. All right, so we are going to use these three as simple fundamental building block for our lesson in probability. Okay, so because of the length of this lesson, we are going to have it into three parts. Okay, so for today we'll be looking basically at the coin, and in the next lesson we'll look at the dice. Then the next one we will look at the playing card. All right, so but for today we take a very close look at the coin. Every coin has two sides, which are the head and the tail. Okay, so whenever a coin is tossed, the only possible ways that the possible outcomes out of that tossing of that identical coin is actually two, because either the head will show up or the tail will show up. So those are the only two possible outcomes whenever a coin is tossed. So we say the outcome for tossing a coin is actually two. All right, so that be the case, let's see what we have to do here. We say a coin is tossed. What is the probability of tossing? A tail, B, a head, C, a tail or a head, and D, a tail and a head. Okay, so in order to determine the probability, the likelihood of tossing a tail or tossing a head, is basically to know the total number of possible outcomes and to also know the event of that identical problem. So for A, the event is that how many ways can we toss a coin and obtain a tail? That's the question. So if you look at the coin, we have only two possibilities when coins are tossed. That is, the head or the tail will appear. So those are the two possible outcomes. Whenever a coin is tossed, we will only have one possibility for a tail to appear. So that becomes the event of having a tail appearing. Okay, so we say for the tail to appear, the event is only one. So it means the probability of a tail appearing is 1/2. And probability can also be written in terms of percentage. Okay, so 1/2 is just the same as 50%. So we have a 50% chance of a tail appearing. Okay, so for B, a head. So we have the probability of a head appearing is also 1/2, because there is only one possible way for a head to appear when a single coin is tossed. So we say the event is 1 divided by the total number of outcomes. So we have 1/2. That will also be equals to 50%. So we have 50% chance of a head also appearing. All right, so C says a tail or a head. A tail or a head. So what's the even for this identical scenario, for this instance? For this instance, the even is actually 2, because if a head appears, it satisfies this instance. If a tail appears, it also satisfies the instance, because it says a tail or a head. So either a tail or a head can appear. So we have 2 instances that can satisfy, 2 events that can actually satisfy the instance. So we say the even is actually 2, and we know the total outcome is 2. So the probability of a head or a tail is actually 2 over 2, which is equals to 1. Or better say, 1 is the same as 100%. So we have a 100% chance of a head or a tail appearing. And this is a tail in a head. So what's the instance where, what's the even for a head in a tail to appear when we toss a coin? There is no possibility. There's no possibility for you to toss a single coin and you have both the head and the tail appearing. It's never going to happen. It's never going to work. So we say the event is actually 0, because there is no possibility in there for the head and the tail to appear at the same time. So we say the probability of the head and the tail is actually 0 over 2, which is actually 0, or also equals to 0%. All right. So we see that the probability is actually the likelihood of something actually occurring. So if you look at the probability line, it tells you that the probability is actually between 0 and that of 1. Okay? For every probability of 0 means that identical event can never occur. But for a probability of 1, it means it's a certainty. It must. It can always happen. Okay, like in the case of C, it can always happen. It means this is a possible way of things happening. Okay, so that's basically how probability works. Now let's see a second problem. Suppose you toss 3 coins. What is the probability of 3 heads? B, at least 2 heads and at most 1 tail. C, 2 tails, 1 head. All right, so what we would love to do always is to find the total number of ways, total number of possible outcome of that identical instance. All right, so how do we find the total number of ways that this can occur when 3 coins are tossed? What are the different possible outcome we can get actually from there? In order to know that, we usually use what we call the tree diagram. We usually draw our tree diagram, and then we can be able to determine how these outcomes can actually occur. Okay, so let us do our tree diagram. So we have the coin and we draw our tree diagram. So at each intersection of these branches, we will have either a head or a tail. Okay, but then how does it occur? Now, when the coin is tossed, when 3 coins are tossed, the first coin will definitely have a head or a tail appearing. So we have the head or the tail appearing. Now, there's a possibility that the head of the first coin actually appears with the head or the tail of the second coin. So that is a possibility. So we have the head of the first coin either appearing with the head or the tail of the second coin, or the tail of the first coin appearing with the head or the tail of the second coin. All right. Now, for the tail coin, there's a possibility that you will have the head of the first coin, the head of the second coin, or the head and the tail, or the tail of the tail coin. Or better say, the head of the first coin, the tail of the second coin, and the head or the tail of the second coin, of the tail coin. or better say, the tail of the first coin, the head of the second coin, and the head or the tail of the third coin. Or better say, the tail of the first coin, the tail of the second coin, and the head and the tail of the third coin. So this would be the possible outcome whenever three coins are tossed. So either you will have the head, and the head, you have the head, and the tail, or you have the head, the tail, and the head, or you have the head, the tail, or you have the tail, the head, and the hair, and you have the tail, the head, and the tail, or you have the tail, the head, or the tail, and the tail. Okay, so those are the possible outcomes whenever three coins are tossed. Either you will have all three of them appearing this way, or either of these ways. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that would be 8 outcomes. Okay, so we say that we will have basically 8 outcomes whenever three coins are tossed, and these are the possible ways that they could appear. So we were saying that these are the sample space. Okay, so because the sample space is the set of all the total possible outcomes. Okay, so that becomes the sample space. Now A says, what's the probability of three heads appearing? Okay, so we now have A, it will just be, so the probability of even A. So even A is 3 heads. Okay, so in other words, we say the probability of 3 heads. So we are going to look in here for the possible ways that this event 3 head can appear. So we have this 3 head can appear here. So if you look here, the only way that 3 heads can appear is only one way. So we say the event is 1. Okay, divided by the total number of outcome we know is 8. So it becomes 1 over 8. So 1 over 8 is the probability for 3 heads appearing. And B says at least 2 heads and at most 1 tail. Okay, so at least 2 heads. Okay, so at least 2 heads. So let us see. Okay, no. We have 1 head. We have, okay, this. We have 2 heads here. We have 1 head. We have 2 heads. We have 2 heads. We have 3 heads. Okay, this is part of it as well because it says at least 2 heads and at most 1 tail. So, at least 2 heads. It means 3 heads also form part of that set, and at most 1 tail. So whether you have a tail or not, but you can have more than 1 tail. So that's a possibility. So those are the 4 possible ways that we can have at least 2 heads and at most 1 tail appearing. So we say the total number of ways this event can occur is actually 4. Okay, so we say the probability of B, meaning the probability of at least 2 hairs and at most 1 tail is equals to 4 divided by 8, which is equals to 1 over 2. Okay, so let's see for C. C says 2 tails, 1 head. 2 tails, 1 head. So exactly 2 tails and 1 head. So here we have 2 tails, 1 head. Here we have 2 tails, 1 head. Here we have 2 tails, 1 head. Okay, 2 heads, 2 heads. Okay, so we have 3 ways. So the total number of ways the event can occur is actually 3. But the total number of outcome for this identical scenario is 8. So we say the probability is 3 over 8. Okay, so that's basically it, and thank you and see you in the next video.